Oh, that's nice, Morgan. That's really nice. Your cat had 3 kittens. I love those memories. I had one cat have a litter, and as a kid, it was just so fun. And then I had, like, whenever I was a kid, one of our dogs had a litter of puppies, and it was just so fun. You're already preparing for April Fool's, Josh? Is April Fool's to January, February, March? April Fool's is in 2 days, right? Hi, Miriam. Okay, y'all be prepared on Friday because Friday is April Fool's, and Josh has something up his sleeve, so make sure. I will not be spitting out any April Fool's jokes, just so that y'all are aware. If I tell you to do your homework, it's not April Fool's. Just don't use that on me. Here are the slides for today. If y'all want to go ahead and click on that, and we have a couple announcements. Let's see here. Okay, first of all, let's see. Let's get the slideshow going here. Okay, first of all, the main announcement is that we have a small group study session happening tomorrow at 11 a.m. We used to have them on Tuesdays. Now we're having them on Thursday at 11 a.m. So if that's something you're interested in, basically it's like an hour and you can come for part of the time or just like 5 minutes or the whole time. And you're like, it's just to hang out with other people while we're all working. And a lot of the people may be working on the same assignment as you, or they may have already done it. And so y'all just like talk with one another or just like quietly join and then ask questions when you need help type thing. Like you can turn the volume down and then ask questions when you need help. And some of y'all don't like coming to me one-on-one because apparently y'all think I'm really scary. I don't know why some of y'all don't come and talk to me, but a small group study session, there's other students there. You're not like just one-on-one with me. And so I would encourage you to join. So right now you're allowed to get out your phone, not that I can see them anyways, but put a reminder on your phone tomorrow at 11 a.m. to join if you want to, if you're interested in doing that. So real quick, set your phone reminder. Okay. So that's the main announcement. I'm also having some other small group study sessions. If you've gotten that invite, if you've gotten some text from me this week, you may have been invited to some smaller study sessions. Anyone's welcome to join them. That's just to get caught up on assignments. And so if you want to join those, they're also on Thursday at 1 p.m. and Friday at 1 p.m. So just know you're welcome to come to those two as well. Thursday at 1 p.m. and Friday at 1 p.m. And yeah, Brenda, we can definitely set another day. Like I am doing some study sessions on Thursday and Friday at 1, and then we can maybe set up some more if y'all want to. So that's the main announcement. This is food for thought here on this slide. Hold on, let me share the slides again because I think some of y'all joined a little bit later. So there's the slides. So if you guys are interested in this video, the question is, can you unboil an egg? So imagine that you have a pot of boiling water, you boil the egg. Let me just tell you, the perfect time is 7 minutes on the dot to boil an egg. You should try it. It's so good. 7 minutes, you boil an egg, and then now you have an egg that's completely different. Can you change it back from like a solid egg white and a cooked egg yolk? Can you change that back into a regular egg again? Because if you think about it, it's made of the same chemicals, but it seems impossible to take it back. And if you watch this video, and if we have time at the end, we will watch it. It just like is interesting. It's like, can you do that? And have they tried to do that? So some of y'all are saying no. Josh is saying use a time machine. That would be ideal, definitely. If I had a time machine, the first thing I would do is unboil an egg. I'm just kidding. So we'll go back to that if we have time. I'm not sure, Velvet. I don't know what type of eggs you're talking about there. Okay, so here's some objectives for today. You're going to learn how to write half reactions, and then you're going to learn how to balance them. So we're learning 2 things today: how to write a half reaction, and then how to balance the reactions after we write them. So let's just review what we learned last week. So last week we learned about a redox reaction. Re stands for reduction and ox stands for oxidation. So a redox reaction is when one thing gets oxidized and one thing gets reduced. One thing gains electrons and one thing loses electrons because they're exchanging them. Like one gave an electron to another, so one became more positive and one atom became more negative. And that's called a redox reaction. The atom that has an increase in oxidation state is oxidized because it loses electrons. The atom that has a decrease in oxidation state is reduced because it gains electrons. And you can remember that with the phrase or with the acronym oil rig. Oil rig stands for oxidation is losing, reduction is gaining. So oxidation is losing electrons, reduction is gaining electrons. That's what we learned last week. And then I made this pretty picture. Do y'all think it's pretty? Because I made this myself. Do you see how I like made the sphere? It looks three-dimensional because I did the lighting on it. So do y'all think that's cool? Or okay. Josh says kind of. Ouch. Okay, so Josh thinks that this picture is kind of cool. I made it for you guys, so no big deal. Thank you, Desari. I appreciate it. I'm just trying to get all the compliments over here. So this is an oxidation reduction reaction. So look what happens to A. The A starts off at 0. It has no charge. And then at the end, it has a positive charge. So the only way for that to happen is that A gave away an electron. It gave away 1 electron. And then if you look at B became more negative because it took A's electron. So it became more negative, and an electron was gained. Another way of saying that is when something's oxidized, it becomes more positive. And when something is reduced, it becomes more negative. So if you think about it, it kind of makes sense to me because reduced means like lower, right? It got reduced. So it got more negative. And then something that's oxidized gets more positive. And you guys have probably heard of the word oxidized before. Like if you think about metal that's being oxidized, right? You've heard that phrase before. Or if you do your makeup, you know that like girls will be like, the coloring, it got oxidized. And so the color turned to like more orange, right? So oxidized means that something is becoming more positive. It's losing electrons. Okay. And then Rhonda, I'll answer your question in a minute. You can always join my like one-on-one class if you want one-on-one tutoring. I'm here all day for that. Okay, so now we're going to learn about half reactions. Let's see. So what are half reactions? Well, a half reaction is kind of like half of the reaction. Okay. So we'll talk about like, okay, what does that actually mean though? A half reaction, it shows either the oxidation or the reduction component of a redox reaction. So it splits it apart so that it's just showing the oxidation part and then just showing the reduction part. So let's look at this reaction right here and look at what the half reactions would be. Okay, let's see here. So here's the picture. Let me show you what a half reaction would look like for A and B. So for A became more positive. So A lost an electron. Okay, so the half reaction would show A with its original state of 0, and then the final A with a positive charge plus an electron because it lost an electron here. And we're not really showing it, but you can see that if it became more positive, it lost an electron. And then for the reduction half, we can show B, and then a B became more negative. So it gained an electron right here. So we're showing it on this side. So this is a kind of a simple example of two half reactions, A and B. We're showing how both of them got oxidized and reduced there. And so we're going to do some example problems. So click on this Jamboard link here to go over here. And I can also put it in the comments here. Let's see. Here is the Jamboard link that y'all can click on. And we're going to start with slide 1. So let's see. Hold on one second. Okay, so slide 1 says identify and write equations for the half reactions here. I actually copied and pasted this wrong. This should not be here, and this should not be here. Okay, I'm realizing that. Okay, so those should not be there. Let me share my new screen here. Okay, so we're going to work this problem. We're going to write the half reaction. So let me rewrite this because the first time I did it, I copied and pasted the wrong letters over there. So we need some like music while I'm writing this. Okay, so now that's done, and we're going to write the half reactions. So we're going to split it apart and show what's actually happening. So before we do that, if you notice, this right here does not show like MnO4. We need to figure out what the O's charge is and what the manganese's charge is. So we need to go look up their charges on the periodic table. So how many of you guys know oxygen's charge? Does anybody have it memorized? Oxygen's charge, anyone? Yes, Velvet, -2, great job. If you don't know the charges, then put a note and message me, and I'll, there's like a list of charges, okay? So I can give you that, you don't have them, okay? I can give you that list later, I don't have it right now, but it just shows in the columns, like each column has certain charges. So oxygen's charge is -2, okay? Actually, I'm gonna write it beneath here. I need y'all to track with me here for a second. So oxygen's charge is -2. How many oxygens do we have? How many oxygens do we have here? Thank you, Velvet. Yes, and then Josh, thank you. It was in the slide from last week. How many oxygens do we have right here? It's not a trick question. 4, great job. Okay, so that makes the charge on this side -8 because each one of them has a -2 charge, right? And there's 4 of them. -8. We don't know manganese's charge. It doesn't show it on the periodic table. So it's like we need to figure out what it is. And the overall charge is -1, right? So what does this need to be for the overall charge to be -1? It would be like x minus 8 equals -1. What does x need to be to get the overall charge to be -1? Yes, 7. Great job, Julia. If we add 8 to both sides, 8 minus 1 is 7. So manganese has to have a charge of +7 here, okay? And then oxygen has a charge of -2. So that one was a trickier one, which is why I'm doing it with you guys, because this one was a little bit of a harder one. Now we're going to write the half reactions. So first we're going to take manganese and we're going to write its charge up here. And then look at what happens to manganese. Its charge goes down to just +2. So is that being oxidized or reduced? Is manganese being oxidized or reduced? What do y'all think? Reduced. Great job, Ari. So manganese is being lowered. Do you see its charge is getting lower? So in order for that to happen, on this side, it would need to add an electron because electrons are negative, right? How many electrons would it need to add to get to a charge from 7 to 2? How many electrons? Close. You got it. 5 electrons, right? Because 7 minus 5 makes 2. And so it would need to add 5 electrons there. So this is the reduction half right here. This is the reduction half. Now we're going to do it for iron. Iron's a little bit easier. So it started off with a +2 charge, and then it gained, it has a higher charge now. And it must, if it went from +2 to +3, it must have dropped off an electron because 3 minus 1 makes 2. So all of these are just kind of like math problems. 7 minus 5 makes 2, and 3 minus 1 makes 2. So you just kind of make the math add up. And these are the half reactions. This is the reduction half, right? And this is the oxidation half. So this one was a little bit harder. We're going to try one more here and see if you can write the half reactions for this one here. That is a great question, Velvet. Velvet's asking why is the O not on this side? And the answer is that it should be, and we're going to address that in a minute. There actually is an oxygen on the right-hand side. This is kind of a weird way it's written, but if you hold on, Velvet, you'll see in a minute that there is going to be an oxygen on the right-hand side in just a minute, because there is no way for O to cease to exist. That's a great question. So now let's try this one. Let's write the half reactions. So if you notice, Fe is just plain Fe, so its oxidation state is 0. Copper is just plain copper. When an element is by itself, its oxidation state is 0. So now let's write the half reactions. So let's start with copper. Copper plus, and then on the right-hand side, you see how I went to copper 0? So now I need to figure out, do I need to put the electron here or here? So we need to work out the math. So we need to make the math work out. So +1 minus 1 makes 0, right? So we need to put the electron on the left-hand side right here, because +1 minus 1 makes 0. Is that kind of making sense on why we put it on this side to make the math work out? Great job, guys. And is the copper here being oxidized or reduced? Thank you, Ari. I appreciate the backup there. Is copper being oxidized or reduced here? What do y'all think? Oxidized or reduced. Great job. It's being reduced. It's getting lower over time. Thank you, Julia. Thank you, Ari. Now, this is the half reaction. Like when a question says write the half reaction, this is what it's asking you to do. And now we do it for the iron, the Fe. So we went from 0 to +3. So the only way to make this math work out is if we added 3 electrons here, because 3 minus 3 makes 0, right? And this is being oxidized because we're increasing our charge. And so now we've written the half reactions for both, and that's our final answer there. Is that making sense? Because there are 2 things we're going to learn today: write half reactions and then balance them. Okay, so now I'm going to flip back over to our slides. Awesome. We're going to learn how to balance redox reactions. This can be a tough one for some people, and we're going to just break down the steps of how you do that. So first, you write the half reactions. That's the first step, and we've already done that for both of those. Second, you balance the half reaction, and I'll explain how to do that in a minute. So you balance everything, you balance the charge, and then you balance oxygen using H2O and balance hydrogen using H+. So I'm going to explain what that means in a second. The best way to show you is to just do the steps with you guys and explain it. So I'm gonna explain how to balance the same reaction that we just did. So I'll keep these slides up if you want to look at those on your own. But we're gonna jump back to the Jamboard, and we now are going to balance this reaction again. So this was the same one that we did earlier. So we're gonna rewrite the half reaction again. So remember, it was Mn with the 7+ charge plus 5 electrons makes Mn 2+. And then it was iron with its 2+ charge makes iron with a 3+ charge plus 1 electron. So that's what we did in the last lesson. So to balance it, now we have to actually balance this reaction. We need to make the electrons the same number. So for example, there are 5 electrons here, but only 1 electron here. And that doesn't make sense, because if one thing is leaving off 5 electrons, then those 5 electrons need to be picked up. So they can't just disappear. So we need there to be 5 electrons here as well. So we need to multiply everything in this reaction by 5. So 5 here, and 5 here. Does that make sense? So we keep it consistent by multiplying everything by 5, right? So now we're going to rewrite the reaction. It's MnO4 plus 5Fe, we're rewriting it, makes 5Fe3 plus Mn 2+. So now we have our new reaction, and we need to make sure everything's balanced. We balanced the electrons by multiplying by 5, right? But now, like Velvet said, why is there an oxygen on this side but not oxygens on this side? Well, if the oxygens aren't balanced, we need to add H2O to that side. So we need to add water over here, because there's no way that, like, this reaction has to happen in water, or it's going to produce water, because there's no way that oxygen just disappears. So we're going to tack on water on this side. And if you notice, there are 4 oxygens here, 4 of them. So I need to put a 4 right here, because that 4 multiplies out, right? So now I have 8 hydrogens there. 4 times 2 makes 8. And I have 4 oxygens. Is that making sense on how that 4 multiplies out? I have 8 hydrogens and 4 oxygens now. Making sense? Thank you, Tobias. Okay, so now my oxygens are balanced, my ions are balanced, and my manganeses are balanced. What is not balanced? There's one thing here that's not balanced. Anybody can see? Each atom on the left and the right-hand side need to be the same number. So there should be, 1 manganese on the left and 1 manganese on the right. There's one thing that's not balanced. Which one is it? Any guesses? There's something on the right-hand side that's not on the left. Now we've balanced our oxygen. See, we have 4 here and 4 here. There's one that's not balanced. Y'all are missing it. You're looking right over it. So let's look at what we added on here. We added H2O right here, right? So now we have 8 H's on the right, but no H's on the left, right? So the H's are unbalanced. Does that make sense? Yeah. So we added it on here. So when that happens, when your H's are unbalanced, you can add H plus on the right. Okay. And we need to tack an 8 in front of it, an 8, because there were 8 here. And so there need to be 8 here. And so now this is our balanced equation. First, we wrote the half reactions. Then we balanced the half reactions and plugged them back in. And then we added in H2O and H plus to make the equation balanced in that way as well. Does that kind of make sense? So this was a harder one, and we're going to try one more that's a little bit easier from the other one, right? So we're going to balance this one now. So remember earlier we had this reaction written like this. And then we had the iron written like this, Fe3 plus 3E. So are the electrons balanced here? Are the numbers of the electrons the same on both sides, like on both equations there? Do we have the same number of electrons on the copper equation as we do on the iron equation? Everybody look real quick. Are the electrons balanced here? Are the numbers the same? What y'all think? Joshua says yesn't. Is that a yes and a no just in case? Okay, let's look. How many electrons do I have here? How many electrons? Everybody type in. How many electrons do I have? Thank you, Josh. One electron. How many electrons do I have here? 3. So that's not balanced, right? Because the numbers aren't the same. So what do I need to do to the copper equation to get them to be the same? Thank you, Savannah. What do I need to do to the copper equation to make this balanced here? Balance. I love it. Okay. So we need to multiply everything by 3. So I need to put a 3 here, a 3 here, and a 3 here. So that now I have 3 electrons here and 3 electrons here. So now my electrons are balanced and I can go back and plug them in. So my coppers now have a 3 in front. I'm just going to rewrite the equation like this. But I'm putting a 3 in front of the coppers because that's what we did here to balance the electrons. Okay, so I put a 3 here and a 3 here. And this is my final answer because everything else is balanced. I have 1 iron here and 1 iron here, 3 coppers here and 3 coppers here. And so the entire equation is balanced already. Is that kind of making sense on that one? Okay, it's showing them here too. Like these are all written out here for you to look at later if you want to remember how to balance these half reactions here. Let's see here. Yes. If you want to look at that, I think we've done this one too. Awesome. Awesome. Here's our code word for today. And so are there any questions on what we just learned here? Any questions at all? Okay, I want to take a minute real quick. I don't know if we're going to be able to watch the how do you unboil an egg, but if y'all want to watch it on your own, you can. But I want to take a second to hear your comments, since we have a minute, on what is a chemistry topic that's interesting to you. Maybe we're not really learning about it, but you would like to learn about it. Or maybe you have a specific question about science that you are interested in. What's a science topic? Just as your exit ticket. I want to hear one thing that you're interested in learning about relating to science, or if you can be specific, chemistry. I want to hear like how I can help help you learning chemistry. So as your exit ticket, put in the comment here what chemistry topic you're interested in learning. And then remember that tomorrow we're having a study session at 11 a.m. And you just need to join, and it's not going to be tough at all. Like it's going to be super fun and it'll help you get through some assignments. Botany is the only science. Okay, interesting. I want to hear like specifics if you can. Tell me like specifically what you're interested in chemistry. And you can, you know, astrophysics, biochemistry. I love biochemistry. It's my favorite class in college. Quantum physics and biochemistry. Okay, we got 2 biochemistries. You can be as specific as you want, like even within biochemistry, what's interesting to you? Or like one topic that, like, if I can do like a topic at the beginning of class each day, you know, human chemicals. Okay, interesting. Oh, that's cool, Christopher. That's interesting. Yeah. How modern consoles are built and runs smoothly. That is basically a chemistry question. It's like an application of chemistry. Quantum physics. Kenward, I just had a conversation with my husband on the fourth dimension. I was trying to wrap my mind around it and we talked about it forever. I'm like, what is the fourth dimension? And it's like impossible to wrap your mind around. That would be an interesting, like at the beginning to talk about next week is like, what is the fourth dimension? How can we imagine it? How rocks turn into diamonds. Okay, these are interesting. I'm liking these comments here. When you comment, you guys are good to go. Or you can stick around if you want to. Forensic science, that all of these are valid for sure. These are super interesting and science related. What goes on inside the body, nuclear chemistry. Love it. Quantum physics. Okay. That's awesome. Gabriella says she doesn't know. Okay, that's okay. Have a great day, Brenna. Bye. Quantum physics. I don't know that theory, Tristan. Oh, DNA. Okay, Gabriella. I thought you said don't know for DN. That's really funny. That makes more sense. DNA is super interesting. All right. The fourth dimension again. Okay. I'll have to talk about that sometime. When y'all put your comment in, y'all are good to go. You're writing what topic, what science topic you're interested in learning more about. And if you could talk about chemistry, that would be helpful, but it could be any science concept. That's cool. Fourth dimension sounds good. Um, Theoretically, the fourth dimension is real, I think, right? Just like the second dimension is real and the third dimension is real, right? Think about how you would explain to something in the second dimension on a flat plane what the third dimension is, Tristan. Think about that. How could you explain to them what it would be to have stacked layers rather than just one layer? It's crazy. Think about that. Anybody else? Science topics are interesting. Marine biology, you love everything about it. That's so cool. Ari says tacos. Tacos are science related. Love it. Wormholes. Interesting. White holes, black holes. Those black holes scare me so badly thinking about that. I remember as a kid, I thought that they were fake. I didn't know that they were real. And when somebody told me that, I was like, you're telling me that a black hole is real? That is so scary. Yeah. That's so cool. All right. If you guys are white holes, I didn't know about white holes though. I've never heard of that. If you guys are still typing, go ahead and keep on working. But if not, y'all are good to go. Or if you have any questions, you want to hang out and chat, that's totally fine with me too. I need to look into this, Ari. I didn't know about that. Still learning about it. Okay, I need to look into it.